Tangam. Welcome to GullyClassroom. This is the fourth lecture in the chapter Acids, Bases and Salts in CBSE 10th Standard Chemistry Science Book Chapter 2 Acids, Bases and Salts. This is the fourth lecture taken in English. Sir, what are we going to learn in this particular lecture? In this particular lecture, we are going to learn about different applications of acidity and basicity. What are the different ways in which acids and bases are affecting our daily life? We will also learn about what is strong acid, weak acid, dilute acid and concentrated acids, and we will learn about pH scale. Let us start this particular lecture. Yeah, can we start this lecture? Come on guys. The first topic we are going to learn now is dilution. We already learned what is dilution in the last lecture. What is dilution? Dilution is simply mixing of water with acids or bases. Dilution is simply mixing of water with acids or bases. It is a highly exothermic process. Here, how to write the definition of dilution? Mixing of an acid or base with H2O, with water, which results in decrease in H3O plus ions or OH minus ion concentration per unit volume. So, you are going to mix water with acid. Hence, there will be a decrease in the amount of H3O plus ions in unit volume of the acid. You are going to mix water with base. Hence, there will be a decrease in the concentration of OH minus ions per unit volume. Sir, how am I supposed to understand this? Let us say you have some milk with you. You are constantly mixing water with it and tasting 1 teaspoon of it. What will happen? Slowly the essence of the milk will get diluted. You will only taste water at some point because the amount of water is increasing. You are putting more water in, so the effect of the milk is decreasing. The effect of the milk on the taste is decreasing. In the same way, when you are mixing water to acids or bases, the amount of hydronium ion in acids and the amount of hydroxide ion in bases is constantly decreasing with respect to a unit volume. This is called as dilution. The acids and base are said to be diluted. So, what is the basic difference between concentrated acid and dilute acid? First, an acid behaves as an acid only when there is water. A base behaves as a base only when there is water. But if there is very large amount of water mixed with the acid, what happens? The effect of the acid is decreasing because the amount of H plus ions in a unit volume of the acid is decreasing. This is called as dilute acid. If you have more water, if you mix more water to a acid, it is called as dilute acid. If you mix less water to a acid, it is called as concentrated acid. In simple words, in dilute acid, the amount of water is more, acid is less. In concentrated acid, the amount of acid is more, water is less. The amount of water is less. Are you able to understand the difference between concentrated acid and dilute acid? Concentrated acid means this acid contains less water, more acid. Dilute acid means this acid contains more water, less acid. So concentrated acid is dangerous as it is more corrosive, as it contains more hydronium ions per unit volume. As it contains more hydronium ions per unit volume. Yeah, are you comfortable with the idea of concentrated acid and dilute acid? Any acid can be made as dilute acid or concentrated acid. If you have more water, that particular hydrochloric acid, it can be called as dilute hydrochloric acid. If you have less water, that particular hydrochloric acid can simply be called as concentrated hydrochloric acid. Let me try to answer this particular question. How is the concentration of hydronium ions affected when a solution of acid is diluted? When a solution of acid is diluted, the concentration of hydronium ions is decreasing per unit volume. I just gave you the example of tasting a tumbler of milk by adding water. Tasting a tumbler of milk by constantly adding and adding water. Okay. So, on diluting an acid, on the dilution of a solution of an acid, the concentration of hydronium ions per unit volume. How much hydronium ions is found per unit volume? What is per unit volume? Unit volume can be assumed as per your convenience. It can be 1 liter or it can be 1 milliliter. Okay. So what is the next question? Why do HCl and HNO3 show acidic characteristics in aqueous solutions, while the solution of compounds like alcohol and glucose do not show acidic characters? HCl and HNO3 are not showing. What are they not showing? They are, HCl and HNO3 are showing acidic characters. Why? First, let us take HCl. If you take HCl can be broken into two parts. HCl can be broken into hydrogen ion and chloride ion. In the same way, let us take the next acid, HNO3. HNO3 means nitric acid. It can also be broken into two parts, H plus or hydrogen ion, NO3 minus or nitrate ion. So when hydrochloric acid and nitric acid are mixed in water, when they are mixed in aqueous solutions, what is formed? Hydrogen ion is formed. Because hydrogen ion is formed, HCl and HNO3 show acidic characters in aqueous solutions or in water. What about alcohol and glucose? What is the formula for alcohol and glucose? A good example for alcohol is, I am going to write methanol, CH3OH. This is methanol. Methanol is a good example of an alcohol. Okay, sir. What is the formula for glucose? The formula for glucose is C6H12O6. The formula for glucose is C6H12O6. Both methanol and glucose contain hydrogen, but this hydrogen does not form H plus ions when it is mixed in water. Even though alcohols and glucose contain hydrogen, they do not dissociate to form H plus or hydrogen ions. They do not dissociate to form H plus or hydrogen ions when mixed in water. Hence, the solutions of compounds like alcohol and glucose do not show acidic properties because no H plus ions are formed when they are dissolved in water. Are you able to understand how I am analyzing this particular question? Yeah? Okay. What is the difference between strong acid and a weak acid? What is the difference between strong acid and a weak acid? A strong acid is an acid where there is complete ionization. Sir, help me understand this particular word, complete ionization. Let us say there are 10 molecules of hydrochloric acid. Let us say there are 10 molecules of hydrochloric acid. If I am putting this 10 molecules of hydrochloric acid in water, all the 10 molecules of hydrochloric acid will dissociate, will break and form H plus ions. So if I am putting 10 molecules of HCl in water, 10 molecules of hydrochloric acid in water, I will get 10 hydrogen ions, H plus ions. Such kind of complete ionization is called as strong acids. Acids where each and every molecule of the acid dissociates to form hydrogen ions when mixed with water. Let me repeat myself. Each and every molecule of the acid dissociates to form H plus ions when mixed with water. When mixed with water, it is called as strong acid. So what is weak acid? Let us say I have a particular acid. If I am putting 10 molecules of this particular weak acid in water, only 3 molecules are dissociating to form H plus ions. If I am putting 10 molecules of weak acid in water, only 3 molecules are dissociating to form H plus ions. Such a type of acids where only partial ionization is happening, or acids that do not completely ionize in aqueous solutions and form H plus ions are called as weak acids. So a good example for strong acids is hydrochloric acid, nitric acid and sulfuric acid. Most of the mineral acids, in fact all of the mineral acids are strong acids. Acids that are derived from the minerals that are obtained from the earth are called as mineral acids. Hydrochloric acid, nitric acid and sulfuric acid are mineral acids. They are strong acids. Give some examples for weak acids, sir. Acids that are usually produced in our body are called as weak acids. They can also be called as organic acids. Good examples of such acids are HCOOH, formic acid, CH3COOH, acetic acid. Acetic acid in fact can be also called as vinegar. Acetic acid in fact can also be called as vinegar. Okay, what is the next thing? The next thing is citric acid. All the acids that are found in food are also organic acids. All organic acids can be simply classified as weak acids. Oxalic acid from tomatoes, tartaric acid from tamarind, what else? Lactic acid from curd, citric acid from all the citrus fruits, and so on. Such acids that we learnt in the first lecture are good examples for weak acids and organic acids. Yeah, they are examples for weak acids. Are you comfortable with the idea of strong acids and weak acids? If all the acid molecules undergo complete ionization, it is called as strong acid. If all the acid molecules do not undergo ionization, they only undergo partial ionization, they are called as weak acids. Okay, let me try to answer this particular question. Why does 1m HCl solution have a higher concentration of hydronium ions than 1m acetic acid solution? Okay, here the term 1m means 1 molar. It is simply a concentration term. Right now you need not learn this. Right now you need not concentrate on this. The only thing that you need to understand here is they are comparing the same amount of HCl solution with the same amount of acetic acid solution. They are taking 1 molar HCl solution and they are taking 1 molar acetic acid solution, and they are finding that there is a higher concentration of hydronium ion where in the solution of hydrochloric acid. Why? Because hydrochloric acid undergoes complete ionization and produces a greater number of H plus ions, because HCl or hydrochloric acid is a strong acid. What about CH3COOH or acetic acid? Acetic acid is a weak acid. It partially ionizes to form H plus ions. It does not undergo complete ionization, so it always has lesser number of hydronium ions than HCl. Lesser number of hydronium ions than HCl. Are you able to understand how I analyzed this particular question? Yeah, are you comfortable with this? Okay, now in order to understand acids and bases further, I need to quantify them. I need to give a particular scale to them. In order to understand acids and bases better, I need to give a scale to them. What kind of a scale am I going to give to acids and bases? I am going to give a scale called as pH scale. pH scale is simply used for measuring H plus ion concentration. Hydronium ion concentration can be easily measured with respect to pH scale. Hydronium ion concentration can be easily measured with respect to pH scale. In fact, pH scale is used for measuring hydronium ion concentration. The scale is from 0 to 14. The scale is from 0 to 14. Totally, it has 15 numbers. From 0 to 14, it has 15 numbers. Here, the value 7 is taken as neutral. The value 7 is taken as neutral. What is the meaning of neutral? In order to understand the meaning of neutral, let me recall a very small topic that I have already taught you. Auto-ionization of water. What is auto-ionization of water? Water automatically breaks to form H plus and OH minus ions. This H plus ion will not be alone. It will try to join with another water molecule to form hydronium ion. So I am going to put H2O. This H plus will not be alone and it will join with another water molecule to form hydronium ion. So I am going to write like this. I am going to write this particular equation. Water breaks to form H plus and OH minus ions. If H plus ions are more, it is called as an acid. If H plus ions are more, it is called as an acid. If OH minus ions or hydroxide ions are more, it is called as a base. Since H plus ions will not be alone, I am adding another water molecule right here and putting hydronium ion over here. Since H plus ions will not be alone, I am adding a water molecule here and putting a hydronium ion. What ion? I am putting a hydronium ion over here. Are you comfortable with this particular equation? Yeah? Okay. So, if there are equal number of both hydronium ion and hydroxide ion, if they are present in equal numbers, they will balance each other and there will be no free ions. If there are no free ions, then water is neutral. Are you able to understand how I am analyzing? If each and every water molecule is breaking and forming H plus and OH minus ions, then it means that there are equal number of H plus and OH minus ions. Only if H plus ions is greater in number, then the solution will become acidic. Only if OH minus ions are greater in number, then the solution will be basic. If both H plus and OH minus ions are equal in number, then they will compensate one another and that particular solution is called as neutral. And then that particular solution is called as neutral. Are you able to understand how I am defining the idea of neutrality? Equal number of H plus and OH minus ions which compensate for one another, then it is called as a neutral solution. Example, water. Okay sir, what if the pH value is decreasing? If the pH value is decreasing, then the solution is becoming acidic. If the pH value is increasing, then the solution is becoming basic. Let me repeat myself. If the pH value is decreasing, if there is a lowering or a decrease in the pH value, then what is happening? There is an increase in H plus concentration. There is an increase in H plus or hydronium ion concentration. If the pH value is increasing, if the pH value is becoming higher, then there is an increase in OH minus ion concentration or the solution is becoming basic. Let us look at a couple of examples. Here 7 is neutral, 6 is slightly acidic, fresh milk is slightly acidic. Okay, let me go further. Lemon juice is acidic, 2.2 is its pH. What about gastric juice, sir? Gastric juice is the digestive juice of the stomach. Its pH is 1.2. It is strongly acidic. If you have a pH of 0, it is very acidic, extremely acidic. Okay, sir. Let us increase the pH value. What about a pH value of 10? Magnesium hydroxide has a pH value of 10. It is alkaline. How much is it alkaline? It is slightly alkaline. A pH of 8 can be treated as slightly alkaline. A pH of 10 can be treated as decently alkaline. What about a pH of 14? Caustic soda or sodium hydroxide has a pH of 14. It is very alkaline. It is strongly alkaline. So if you have a pH of 0, that particular solution is strongly acidic. If you have a pH of 14, that particular solution is strongly alkaline. 7 means neutral. 7 means it is right in the middle. If you decrease the value of pH, 7 means it's right in the middle. It is water, it is neutral. If you are going to decrease the value of pH, it is becoming acidic. If you are going to increase the value of pH, the solution is going to become alkaline. Are you able to understand how pH scale is used to define the acidity or the basicity of the solution? If pH is lesser than 7, the solution is acidic. If the pH is greater than 7, the solution is basic or alkaline. Basic and alkaline can be used in places of one another. It's not an issue. So pH number helps to indicate the acidic or basic nature of the solution. pH number helps to indicate the acidic or basic nature of the solution. Are you able to understand this particular idea? Okay, sir. Can you just teach us some applications with respect to pH in our daily life? We want to learn some applications of pH in our daily life. Okay, let us learn some applications of pH. Let us start with human body. Human body works well in a very specific pH range, which is exactly 7 to 7.8. Human body works well in a very specific pH range, 7, which means neutral, 7.8, which means very slightly alkaline. So human body works in a pH of 7.0 to 7.8. In fact, human blood has a pH of 7.4. Human blood has a pH of 7.4. Okay, sir. Give us very specific examples with respect to our body. First, let us look at our stomach, digestive system. In our stomach, hydrochloric acid is produced in order to digest the food. Sir, give me 1 second. Let me recall a very important biology question where they will ask, what are the functions of hydrochloric acid? The functions of hydrochloric acid are, the first one is, it kills all the pathogens or germs in the stomach. The second one is, it gives an acidic medium for the food to digest. What is the third function, sir? Hydrochloric acid converts inactive enzyme pepsinogen into its active form, pepsin, which in turn helps in the digestion of protein. Yeah. So these are the 3 functions of hydrochloric acid in stomach, and very important question from life processes in biology. Okay, sir. I have already recalled that along with you. Let us get back to chemistry. Here, during digestion, HCl is produced. If in case of indigestion, what is happening? More and more hydrochloric acid will be produced in order to help in the process of digestion. Because of this excess hydrochloric acid, what will happen? Pain and irritation will be caused. This pain and irritation in the stomach is termed as acidity. This pain and irritation in the stomach is called as acidity. Okay, how are we going to cure this pain and irritation? we are having more acid in the stomach. In order to neutralize the acid, let us take some mild base. What are the mild bases preferable for taking here? The mild bases preferable for counteracting the effect of excess hydrochloric acid in the stomach are milk of magnesia. What is the formula for milk of magnesia? MgOH twice or magnesium hydroxide is commonly known as milk of magnesia. What is the other mild base that can be used here? Baking soda. What is the formula for baking soda? NaHCO3. Sodium hydrogen carbonate. NaHCO3. Sodium hydrogen carbonate is in fact called as baking soda. I am not going to go more into baking soda at this particular point because we will study about baking soda in the further lectures. It's a very important topic. Yeah. Okay. So in order to neutralize, in order to counteract the excess acid produced in the stomach in case of indigestion, if we are going to take milk of magnesia or baking soda, because it is acting against the acid. The mild base we are taking is acting against the hydrochloric acid of the stomach. Hence it is called as antacid, anti-acid, against the acid. So antacid means the medicine, example, milk of magnesia and baking soda, that is taken in order to counteract the excess hydrochloric acid in the stomach. Yeah, which is causing pain and irritation. Let us go for the next topic, tooth decay. How does pH affect tooth decay, sir? pH affects tooth decay. Come on, let me give you an idea. Tooth enamel is calcium phosphate. This calcium phosphate tooth enamel is the hardest substance in the body. But even this hardest substance in the body can get corroded. How, sir? By the food part, by the bacteria in our mouth. The bacteria in our mouth acts on the food particles stuck in the teeth. The bacteria in our mouth acts on the food particles stuck in our teeth and produces a lot of acid. This acid corrodes the tooth. This acid destroys the tooth, decays the tooth. And because we need to counteract the effect of this acid in our mouth, what are we going to do? We are simply going to use a base hazard toothpaste. We are simply going to use a base hazard toothpaste. So toothpaste are usually bases, and because we are using bases, these bases neutralize the excess acid in our mouth. They clean the teeth and prevent tooth decay. They clean the teeth and prevent tooth decay. So normally a good toothpaste must be bitter. Let me be very clear. A good toothpaste must be bitter. Sir, but my toothpaste is very sweet, because they are using a lot of synthetic sweeteners. The toothpaste is sweet, but a good normal toothpaste must be a good base, and this must be bitter. Why? Bases are bitter in taste. BB. I have already taught you how to remember it. Bases are bitter in taste. Bases are bitter in taste. Are you comfortable with this particular idea? Let me go for the effect of pH on soil and plants. What is the effect of pH on soil and plants? If the pH of rain is lesser than 5.6, it is called as an acid rain, and this acid rain washes off into the river, and this acid rain decreases the pH of the river, because its pH is lesser than 7, it is lesser than even 5.6, it lowers the pH of the river, and because the pH of the river is lowered, because the pH of the river is lowered, survival of aquatic life becomes very difficult. Survival of aquatic life becomes very difficult. Okay, sir. What about the soil pH? We have a lot of different plants. Each and every plant needs very specific pH levels for its healthy growth. Each and every plant needs very specific pH levels for its healthy growth. So, we can analyze the nature of the soil, we can get the pH of the soil tested, and we can do treatment of the soil with respect to good fertilizers to increase or decrease the pH level of the soil. The soil can be treated with fertilizers to increase or decrease the pH level of the soil depending on what plant you want to grow. Depending on what plant you want to grow. Are you comfortable with this? Let us go for self-defense. There are certain plants like nettle leaves. What is the very special property of nettle leaves? Nettle leaves have stinging hair. What is stinging? Stinging means biting. Stinging means biting. They have stinging hair, and these stinging hair, when they come into contact with your skin, release a particular acid called as methanoic acid. Methanoic acid, the other formula is HCOOH. Let us be very clear. Methanoic acid is called as HCOOH. Methanoic acid is the chemical name. If you want the common name, it is called as formic acid. The common name of HCOOH is called as formic acid. We will learn about methanoic acid even in a better way in the unit carbon and its compounds. Anyway, but methanoic acid, because the nettle leaves are stinging the skin of human beings by depositing methanoic acid. Methanoic acid causes pain and irritation. What are we going to do? Methanoic acid can be neutralized with a mild base. Sir, what is a very good mild base? We can use baking soda. NaHCO3 has a mild base. For what, sir? For neutralizing the effect of methanoic acid in our skin. For neutralizing the effect of methanoic acid in our skin. What about animals, sir? Especially bee sting. Bee stings are acidic in nature. Once more, you can use the mild base, baking soda, NaHCO3, sodium hydrogen carbonate, or it can also be called as sodium bicarbonate, in order to neutralize the effect of the bee sting, which is acidic in nature. Bee sting, acidic, apply mild base. Bee sting, acidic, apply mild base, which is baking soda, to neutralize the bee sting. Okay, sir. Sir, this has been a long lecture. Tell us something totally interesting with respect to self-defense or chemical warfare by animals. There is this particular beetle called as Bombardier Beetle. There is this particular beetle called as Bombardier Beetle. Okay, this Bombardier Beetle releases formic acid in order to frighten off its predators, in order to frighten off its enemies. You can search for a particular video in YouTube which is very fun. A Bombardier Beetle escapes from the stomach of a toad. What is toad, sir? Toad means it is a type of frog. Toad means it is a type of frog. So what are you going to search for in YouTube? You are going to search for a Bombardier Beetle escapes from the stomach of a toad. This is a very interesting video. What will happen in this video? They will show a Bombardier Beetle. They will show how it is attacking others using formic acid or methanoic acid. Then there will be this toad, a frog. It will simply swallow the Bombardier Beetle. The Bombardier Beetle, once it has been swallowed, it will simply release the formic acid. What will the frog do? After some time, the frog will not be able to accommodate the acidity. The acid will corrode the mouth of the frog. So the frog will simply spit out the Bombardier Beetle. The frog will simply spit out the Bombardier Beetle. I strongly recommend seeing this video. It is a very fun video to understand how acids are used by animals for self-defense or chemical warfare. How acids are used by animals for self-defense or chemical warfare. Okay, sir. Let us close this particular lecture with a couple of nice questions. Okay. Let us start a couple of really nice practical questions. Fresh milk has a pH of 6. We have already seen that over here. How will pH change as it turns into curd? Okay, let me tell you something. There is milk. This milk turns into curd. Which is more sour in taste? Is milk more sour in taste or is curd more sour in taste? Curd is more sour in taste, which means curd must contain more acid because acids are sour in taste. Curd must contain more acid because acids are sour in taste. So fresh milk has a pH of 6, but when it is turning into curd, because more lactic acid is produced, this lactic acid gives a pH that is lesser than 6. When we have a pH lesser than 6, that particular acid is more sour in taste. So fresh milk has a pH of 6. When this fresh milk gets converted into curd, because more lactic acid is produced in the curd, the pH of curd reduces. The pH of curd further reduces. Okay, sir. Let us go for the next question. A milkman adds very small amount of baking powder to fresh milk. Okay, why does this milk take longer time to set as curd? So, when a milk is getting converted to curd, we are understanding that the milk is becoming more acidic. Sir, how are we going to prevent this milk from becoming curd? How are we going to prevent this milk to become from becoming more acidic? How are we going to prevent this milk from becoming more acidic? We can simply add a mild base. Which is a mild base? A very good mild base is baking soda. So if you are adding a very small amount of baking soda to fresh milk, what will happen? This baking soda will slow down the process of fermentation. This baking soda will slow down the process of fermentation. What is fermentation? The process by which milk is converted into curd. There are some bacteria in milk. What are the bacteria in milk called as? Lactobacillus. This lactobacillus digests the milk and produces some acid. That particular acid is called as lactic acid. We need to stop this particular process. To stop this process, we can simply add a mild base, which is baking soda. We can add a mild base, which is baking soda. That's basically this particular reaction. Sir, I think I have studied this reaction somewhere. Yes, you have studied this reaction in biology. In biology, in life processes, we will study about the different types of respiration. You will study about respiration that happens in without oxygen, respiration that happens in lack of oxygen, respiration that happens in excess of oxygen. You will have a trident-like diagram in biology book. You will have a trident-like diagram. You will have this kind of a diagram in biology book. This is a trident structure. In Tamil it is called as Trisulam. In this we will learn that when there is a lack of oxygen, what will get produced? You will get lactic acid. Recall that particular topic. When there is a trident like when there is a lack of oxygen in respiration, what will be produced? When there is a lack of oxygen in respiration, lactic acid will be produced. That particular process can be connected here. That particular process can be connected here. Okay, sir. What is the last question? Why curd must not be kept in copper or brass vessels? Curd must not be kept in copper or brass vessels because obviously curd is acidic in nature. It contains lactic acid. This lactic acid will react with the copper and brass and it will result in a change in flavor of the curd. This will result in a change in flavor of the curd. Okay, sir. So, in what kind of containers, in what kind of vessels must curd be kept? Curd can be kept in glass containers or it can also be kept in ceramic containers. Curd is usually kept in glass, stainless steel or ceramic containers. It must never be kept in copper or brass containers because the lactic acid in the curd will react with the copper and it will result in a change in the flavor of the curd. Okay, sir. Okay, sir. I think I am more or less completed with the lecture. There is one particular word that I failed to mention over here. What is the meaning of the word P? P means potence. P means P-O-T-E-N-E-Z. What is potence? Potence means strength. pH, strength of the hydrogen ion is shortened as pH scale, potence of hydrogen ion. What P means potence. In which language, sir? In German language. So pH scale means strength of the hydrogen ion scale. It can be simply given as strength of the hydrogen ion scale. In pH scale, water is neutral, which means it contains the same number of H plus ions and OH minus ions. If pH scale is decreasing, it is becoming acidic in nature. The solution is becoming acidic in nature. If pH value is increasing, the solution is becoming basic or alkaline in nature. Basic or alkaline in nature. Okay, I hope you guys enjoyed this particular lecture. Yeah, I enjoyed taking classes to you guys. If you like our lecture, recommend our lecture to your friends. Subscribe to our channel. Obviously, click the bell icon. Yeah, share our videos in social media. Let us have a lot of fun learning chemistry in depth together. Let us have a lot of fun learning chemistry in depth together. Cheers. Thank you. See you guys in the next lecture. Cheers. Thank you. See you guys in the next lecture. Yeah. Thank you, Dathanga. Thank you.